Hello my dear VLSI aspirants. Welcome to Deep Silicon VLSI YouTube channel. Let's have another design challenge in terms of propagation delay. Guys, here, this is the given design. There is a NAND gate and two NOT gates, and they are also called as inverters. The twist in this design is they said there is a propagation delay, but they haven't mentioned. They said some non-zero propagation delay. Now what about the output? And still they are not asking you draw the output waveform. How the output waveform looks like? Is it stays high output only, low output only, low to high, high to low, or high to low, low to high? So this is what the given design challenge, and we want to crack it. Yes. Okay. For a better understanding, we are moving to graphical representation. The given design is this. It contains 3 NOT gates and 1 NAND gate. The biggest challenge in this question is they said there is a propagation delay, but they haven't given, and all are identical. So whether it is a NOT gate or NAND gate, it has a equal propagation delay. Okay, for better understanding, we are assuming the propagation delay as 10 nanoseconds. The test signal, they said previously it was 0, logic low, and it has shifted to high. This is the test signal. And if you want to draw the output waveform to solve the given question, you need to know the point here. Let's consider this as test bar. If you know test bar signal, then test and test bar signal you can apply. You can perform NAND operation and you can get the output. So here, as there are 3 NOT gates, you can get it as a NOT gate only, because this A bar, whole bar, whole bar, it is A bar only, right? So here, as there are 3 NOT gates, this path will introduce 30 nanoseconds delay. Hence, the test signal has shifted from logic 0 to logic 1. However, the test bar signal will appear change in the output from 1 to 0, because it is a 0 to 1. Now it is 1 to 0, but after 30 nanoseconds. Therefore, from here, after 30 nanoseconds, here we are assuming each box 10 nanoseconds delay. Hence, whatever the change occurred here, that appeared at the output test bar after 30 nanoseconds. Got it? Fine. Now it's time to discuss about the output waveform. Simply it is NAND operation of test and test bar. Here first of all, previously it is 0 into 1, 0 whole bar 1. You will get output as logic 1 till here, right? Now as the test signal shifted from logic 0 to logic 1, there will be change in the output, because 1 1, it is logic 0. Hence here it happens after 10 nanoseconds only. Because of this NAND gate, there is a delay. We are assuming it as a 10 nanoseconds, and you can take it as 20 or some other value. So here after 10 nanoseconds, output is shifted from logic 1 to logic 0. Okay, fine. So here what I am telling is, because of change in the test signal, output is changed like this. Fine. Now again test bar signal also, because it is 1 only, test bar has changed at this point. Let's assume this is 0, this will be 10, 20, 30. Okay, wherever like at 30 nanoseconds the test bar signal has shifted from logic 1 to logic 0, then 1 into 0 0 0 bar 1, we will get output as logic 1, but will you get immediately? No, it has a propagation delay 10 nanoseconds, means from here 10 nanoseconds, after 10, from here it is shifted from logic 0 to logic 1. Hence guys, here the output waveform looks like this, that is, here you can say 0, 10, 20, 30, 40 nanoseconds, etc. This is what the output waveform. Okay. Welcome back. Now guys, from the previous discussion, using graphs, we understood the output waveform is like this. Here, if you see that how the output waveform has changed, it is shifted from logic 1 to logic 0, high to low, and then low to high. Hence, the right answer is option D. It pulses from high to low and low to high. That's it. Guys, here, this is the importance of glitches, or the whatever the consequences due to propagation delay. Yes, so they said some non-zero propagation delay. This is a NAND gate. For NAND gate, if you take the output like 0 0 0 1 1 0 1 1. Now if you see that the truth table y is equals to AB whole bar, we will get 1110. That means whenever the one of the input is logic 0, output is logic 1. And when both inputs are logic 1, output is logic 0. And especially you take these two cases, 0 1 1 0, output is 1 only. That means to a NAND gate, let's assume two inputs. In such case, when inputs are different, output is logic 1 for a NAND gate. Hence, here you take this design, here test signal, and here what you get? Test bar, because this is A bar, whole bar, whole bar. Then it is A bar only, test bar only. There are two different inputs, test bar. Hence, either you get this or this. In such case, output is logic 1, but still, for some time, output is 0 only. From 10 nanoseconds to 40 nanoseconds, let's assume. By assuming each logic gate has a 10 nanoseconds propagation delay. So, this is what here the consequences due to the propagation delay. And see you in the next video. This is Shivram signing off. Jai Hind.